What we're going to look at on this problem is how to find a normal and a tangent to the following equation: x squared minus the square root of xy plus 2y squared equals 5 at the specific point, square root of 3 and 2. So what we need to do in order to find a normal line or a tangent line is take the derivative. And we'll just go ahead and dive on into that process right now. And notice that we're going to have to take derivative of x times y, and we're going to have to take derivative of y squared. And remember, when you take the derivative of y, that's going to be dy dx. Okay, it's no different than if I had said y equals 3x plus 5 raised to the 5th plus 7. When you take the derivative of that, you have y prime. So we're going to have y prime in our derivative when we start working this out, and that's the implicit differentiation part of this. Okay, so that very first piece is not hard, it's just 2x. The next piece, though, is product rule. It's square root of 3x y. So it's the first part, square root of 3x, times derivative of the second. And the derivative of y is dy dx, or y prime, okay, plus the derivative of the first part, which is just square root of 3, times the second, which is y. And then we move on to that last little piece, 2y squared. Well, 2 times 2 is 4, 2 minus 1 is 1, so that's 4y, times the derivative of y, which is dy dx. And you have to add that part in there because that's the chain rule part of implicit differentiation. And if you're struggling to understand that, remember that number one, right now we're doing it because Mr. Hazelwood said so, and number two, we're doing it because we have to make sure that we use the chain rule correctly every time. And when that y has a squared on it, we're going to have to use the chain rule. Okay? All right. Then we want to get dy dx all by itself. So everything without dy dx, we're going to move over to the right-hand side of the equation. That leaves us on the left with just the things that say dy dx in them, and that's why we can move the 2x, the square root of 3, over. All right. Then we're going to factor out the dy dx. That's all that's left. We factor those guys out. We get negative square root of 3x plus 4y, and then we divide both sides of the equation by that. And so our derivative then, the derivative is going to be what's in that green box, negative 2x plus square root of 3y over negative square root of 3y plus 3x plus 4y. So that is our derivative. There's nothing else that we can do with it. That's the derivative that we're going to use. What this gives us is the equation to find the slope of a tangent line. And in order to find the slope of a tangent line, I need a specific point. Well, they gave me that point. It's the square root of 3 and 2. So what I'm going to do is substitute in for x the square root of 3 and substitute in for y the 2, and it turns out that I get 0. So the slope of my line is 0. And if the slope of my line is 0, that's the equation for the tangent line. Okay? And since the slope is 0, that means I have a horizontal line, which means all the y coordinates have to be the same, so I get y equals 2. The normal line is perpendicular to that. The normal line is perpendicular, and so if I have a perpendicular line to a horizontal one, that's vertical, which means that all the x-coordinates have to be the same. And in this case, all those x-coordinates are the square root of 3. So that's how to use implicit differentiation to find a normal to a line and a tangent to a line.